Screencast 18.8, Calculating the Standard Enthalpy Change. Here we're decomposing some chalk. We take some calcium carbonate, we decompose it into calcium oxide and carbon dioxide gas. Sounds like things are getting more random. We would predict the entropy to be positive. The way we calculate this is by looking up some standard enthalpy changes for substances. Here's the values in joules per Kelvin mole. And it's always equal to the values for the products subtracted by the values for the reactants, each multiplied by any coefficients that must be present. Notice that it is not also squared or cubed by those coefficients as we sometimes saw in other cases. So let's go ahead and do it for this chemical reaction, and here it is shown in its entirety. It's the standard enthalpy of the products, there's both of them, minus the reactants, giving us a value of 160.5 joules per Kelvin mole. It's a positive value. That's not surprising, right? The level of order is decreasing. Or as Chang might put it, there are more microstates forming. Here it's done for the Born-Haber process to make ammonia. I would predict a negative value since it's getting more organized, and we get one. And the only thing to note here is that we have some coefficients here. 2 times 193 joules per Kelvin mole. Oftentimes they force you to look these things up in a table, which is unfortunate and a pain in the neck. Make sure you get the right phases right and make sure your units jive, and you should be good. This is a little bit about calculating the standard entropy change for a chemical reaction. Screencast 18.8.